Hi everyone. This is video 1.7 or 1-7, and it's to be watched the weekend of Friday 9/16. And today we're talking about the concept of continuity, which is a huge one in calculus, and it's going to come up a lot. And we need to know by heart the three conditions for continuity, and we need to be able to use them to explain why or why not a function is continuous at a certain point. Okay, so what are the three conditions for continuity of a function? F of x, or sometimes some books will just be like f, but f and f of x would be the same thing. F of x is continuous, I'm abbreviating, at x equals some number a if, and only if, so this would go both ways, if the following three conditions are satisfied. Okay, first, f of a is defined. Second, the limit as x approaches a of f of x exists. Okay, so the function's defined at that x value. The limit as x approaches a of the function exists. And then third, the limit as x approaches a of f of x equals f of a. Okay, so the function's defined, the limit exists, and the limit is equal to the function value. So those are the three conditions for continuity of a function. Now some examples together verifying continuity. Okay, now the book that I got these out of was the book that we used last year. So just follow, write down the example with me. So here's the example from this book I used last year. Is f of x equal to x over x minus 1 continuous at x equals 1? And we're going to explain. Now the explanation is very important, guys. A strong explanation really, on the AP exam is the difference between a 2 or a 3 or a 3 and a 4, especially a 2 or a 3. When I went to the workshop over the summer, they said that, this guy who was conducting it, he was also a grader for the AP exam, and he said that 2s are very frustrating for the graders because it was usually, just something like, weak explanations or something like that, kept them away from a 3. Okay, so this year I'm determined to really try to focus on you guys explaining things well. Alrighty, so if we're going to determine if the function's continuous, we have to check these three conditions, and we're going to check them in order, okay? Because if the first one's the easiest to check, and if that fails, you're done. So make sure you check these in order. All right, well, the first condition is that f of 1 is defined. All right, so I'm going f of 1. I'm plugging in 1 for x, I get 1 over 0, and already I have failed the first condition. I don't have to go any further, guys. I failed the first condition. So now I'm going to explain, and I'm just going to say no, and then I'm going to say, I'll just do period. You can explain it, in your own words, but I'll just say no, and then I'll say f of 1 is not defined, therefore, okay, those 3 dots mean therefore, f of x is not continuous at x equals 1. So that one was easy. All right, we're not going to do that one. So now flipping to the back, we are going to use a piecewise function here that we have to write down. All right, so we're gonna, the next two problems will be regarding the following piecewise functions. So we have f of x. We're gonna have 3 pieces of it. The first piece is a linear function, and that's gonna be for the x values less than or equal to -1. The second piece is a quadratic, so it would be a parabola. And that's for these x values. And then the third piece is a cubic. And guys, you don't have to do this, but not a bad exercise at all to graph this, because it'd be a very nice visual. Okay, so is the function continuous? Is this function that we just wrote down continuous at x equals -1? Why or why not? Well, to determine this, we've got to test each condition. So always test whether it's defined at that x value first, because that's the easiest one to test, and if it doesn't work, you don't have to go any further. So I'm going to go f of -1. I'm going to see if this is defined. Now, -1, which interval or which piece am I going to be using to test f of -1? It's going to be this top piece, all right, because this is the piece that we're using for x is less than or equal to -1. So this is 3 times -1 minus 1, -4, check. The first part checks out. We get an actual number. It is defined. Now I got to do the second part. So I've got to do the limit as x approaches -1 of f of x. Now guys, notice -1 is an end point. So it's not enough for me to just, consider one piece when I'm thinking about this limit. It's at an end point. So I have to think of it approaching from the left and the right, and I'm going to have to use two separate pieces because -1 is an end point here. Okay, so I'm going to go x is approaching -1 from the left. X is approaching -1 from the right. I'm just going to use an arrow diagram, and then I'll go up here and fill in, what this is equal to, if anything. It might not exist, in which case we'd be done. Okay, so -1 from the left, I'm going to be using this first piece, okay, because it's defined for these x's. So approaching -1 from the left, I'm using this piece, and as x gets closer and closer to -1, this is getting closer to 3 times -1 minus 1. All right, so the y's are approaching -4. Okay? And if that wasn't fast for you, if I went too fast, please think about that. All right, now x is approaching -1 from the right, and now I'm on this interval, so I'll be using the quadratic part of the function. So x is getting closer to -1, that's getting closer to +1 minus 5. So the y's are approaching -4. Guys, if the left-hand limit and the right-hand limit agree, if they both exist and they are equal, they are agreeing, that means that the limit is -4. Okay, so that part checks out. The limit exists. We get an actual number. Now, the third criteria is that the limit as x approaches whatever value we're working with, or we're checking continuity at, of the function is equal to the function value. So the limit equals the function value. That is the last condition, and it is, guys, this is -4 equals that is -4, check. All right, so the third condition is checking to make sure the numbers you got for 1 and 2 are equal. All right, now let me just tie this together for my reader. And again, you want to be good at these explanations because this is the difference between college credit or no college credit. Alrighty, so the answer is yes. And then I'm going to list that my conditions are working. So I'm going to say yes. And then I'll say f of -1 is defined, comma. The limit as x approaches -1 of f of x exists. And then finally, the limit as x approaches -1 of f of x equals f of -1. All right, so those are the three conditions. And then I'll say, therefore, f of x is continuous at x equals 1. All right, now my first year teaching this, guys, the students were kind of griping about, having to write all of this out, and I was, I got lazy about it. My expectations were not high enough for them writing this out, and that was bad of me. Okay, so the answer to, do we really have to, list every condition after we've checked it over here? The answer is yes. All right, that's what they're going to be looking for on the AP exam. So we got to get in that habit. Alrighty, guys, so there's that. Now here's the last one. Same function, but we're checking continuity at a different x value. So is the function continuous at x equals positive 1, y, or y not? I've got to check these conditions. So number 1, I've got to see if f of 1 is defined. So up here, which piece am I using for x equals 1? It's going to be this piece here. All right, if that's not clear, please think about why. So f of 1 is going to equal 3. Check. That's defined. 2, I've got to check the limit as x approaches 1 of f of x. I'm going to see what that equals. And in order to do that, I'm going to use an arrow diagram, because 1, again, is an endpoint. So x equals 1 from the left, x equals 1 from the right. X equals 1 from the left, we're going to be in this interval here, so we're using this piece. As x is approaching 1, this is approaching, am I right? Yeah, I'm right. As x is approaching 1, this is approaching 1 plus 5 is 6. Okay. So the y's are approaching 6. Now 1 from the right, we're going to be on this interval now, we're using this piece, and those y's would be approaching 3. The left-hand limit and the right-hand limit, they exist on their own separately, but they do not agree. They are not equal. So this limit does not exist. And guys, we don't even have to check the third condition. It would not work. As soon as a condition doesn't work, you're done. It's not continuous, because all 3 would have to work. All right, so my answer to this one is no. And then I'm just going to say the one that doesn't work. I'm going to say the limit as x approaches 1 of f of x does not exist. Therefore, f of x is not continuous at x equals 1. Okay, guys, so there's that. That wasn't a long video. That was just 12 minutes. Now let me think about the homework. 1.7, 1.8. Let me think. All right, guys, let's just have you do, oh, this is 1.7. All right, 1.6, 1.7. All right, let's have you try numbers 1. Darn. I will just have you do, try number 3, okay? Just try number 3. Yeah, give that one a shot. Okay. And not call me, but email me, guys, if you have any questions. Okay, talk to you later. Bye-bye.